We're going live. Hello, world. My name is Alan, and we're doing some LeetCode problems today. One specific problem, sort of random, but not exactly. It's LeetCode 75. I guess it's one of the more popular problem. Let me share my screen. So this is the problem, maximum number of vowels, if I'm pronouncing it right, vowels in a substring of given length. Given a string S and an integer k, return the maximum number of vowel letters in any substring of S with length k. Vowel letters in English are A, E, I, O, and U. And as I remember, this problem was in the category of sliding window. And that's exactly what it looks like. We'll need to point two pointers and we'll move them and we'll track the maximum number. Yeah. So max count will be, well, we'll start with, in this case, can set as 0. And then I'm just thinking how, so yeah, once we have both pointers, there will be 2 pointers. And once we have, yeah, like there's this 3, so ABC, and we need to know the maximum number of vowels. Yeah, like this will be the moment where there's maximum number, I guess. Yeah, but we'll move that window. It will be sliding. So we can do it in 2 steps. First, get our front pointer at position, and then or we can have one. The front will be going from. Yeah, we'll say that for front. Yeah, so yeah, I'm thinking about naming front pointer, the back pointer. Yeah, we can also call them right and left pointer. Or call them head, tail. Head is going to be 0 until head is, as long as head is less than length of S, head plus plus. So, and we're gonna, yeah, if S at the position of head is vowels is one of vowels, we'll have a map with, if it's one of vowels, what we'll do is we'll say that count plus plus. Yeah, we'll need count, start with 0. We'll have vowels, not vowels. Yeah, vowels, Wolverines is going to be a map of type byte, and for keys and values will be bool, and we'll have in it a true. We'll have, so we'll need, we kind of need a set. Yeah, will be true, and I true O. We'll have an O, and we'll have an AU. So yeah, and by the way, all of them are lowercase English letters. Yes, and count. Yeah, we're looking at this vowel. We count it if it's a vowel. And that's one part of it. But the other part is if had minus k. So the k is that length, maximum length. Let's say it's the length. Yeah, if its length is 1 and head is 1 and head is 0, so we need to add 1. So if basically we want to know if it's more or equal to k. Okay, so that means we have some length. We are into the string for the length of k or more. That means that thing so that position, so we go yeah, head gets to a new position and we count the vowels. But what if we are at 3? And by the way, this is 2. This is 2 plus 1 is 3. So yeah, so this is 2 plus 1. This is 3. This is already we're 3 into. Okay. So we need to be more than 3 into. We need to be at 4. Yeah. Yeah, so if we are more than 3, like here, yeah, we want to remove the count for the previous, yeah, and that would be, so if head is now, if we had is 3, and we need to get work with the 0. So when head is 3, so we need to work with the 0. So this head minus 3, which is the 0, which is what we need. But when head is 2, which is here, that's not enough. When head is 3, basically with 3 or higher, yeah, then at that position we also need to check if, by the way, that should be that. Yeah, so we need to check what is at that position. And if it's a vowel, so if they are more than the length inside, and there is a vowel at the tail, right behind the tail, I would say, yeah. Then we need to say count minus minus. Because if it's not vowel, we don't care. But here we just update max count. I'm gonna say that its max count is max of max count and count, and return return max count. That should be it. That should be it, I think. So we have 2 pointers. One is the head, and it starts with 0 and goes until the end. Goes until the end. But once we are at one step, once we are more than the length into the string, and one more, we take that previous value right behind the tail. That's our second pointer. Yeah, we check it if it's vowel. If it is, if it's not, we don't care, but if it is, then we update the count. And the count, initial count just picks up all the vowels in the first, before the length, where length dip and one more into the string. And after that, this kicks in, this check kicks in. And, but every time we update the max count. So this should be working. Almost. So it says 1. Why would it do so? So initially it will count. Let's test it. It will count 1. Go and count. Then it will hit here and count 2. And at the same time, and after that it will. So yeah, the max is 1 though. But once 2 count 2 happens, it also makes a discount, and so it's 1. Then it accounts for another one without. Oh, geez, the head. Yeah. So we need to say not the head. We need to say this head minus k. Yeah, that the one right before it. Yes, so that should be it. Wrong answer. 7 output. So there is a bug. For some reason, the discounting expected 4, but it only count. So let's see, count 7. So we should 1, 2, 3, 4, 5, 6, 7. So that's 2. And then, no, that's 3. 3 vowels. Then plus 0 minus 1. So yeah, plus 0. No, W is not a vowel. So plus nothing, plus 0 minus 0. Then we move plus 1 minus 1, it's still 2. Then we move plus 1 minus 1, it's here. And then plus 1 minus 0 plus 1 minus 0. And head minus k. Maybe that thing doesn't work well. Head minus k. So at the position of that, so this is 1, 2, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that will be not 10, the index is 9. So we are at index 9. It's more than 7 or equal. And 9 minus k is 2. So yeah, we checked, and when we added that, we reduced the previous one. Now the next, as we get to index 10 and 11, we should be should be added, but that at 3 and 4, they're not vowels. So there shouldn't be, and count should get to 4. So that's, by the way, yeah, so this is, wait a second, this is account for 5. 1, 2, oh no, so OU and E, yeah, so 4. Yeah, so there's obviously a little bug, but it seems to be, but I just don't see it immediately. It's either not counting the OU here at the end, or it's not discounting this. If I'm using the word discounting properly. So head is yeah, so five, 6, 7, 8, 9, 10. So it's 9, 10, 11. Now at 10, he'll look at 3, which is that L, because 10 minus 7 is 3. But initially this, yeah, so maybe our map is not properly. So we have A, E, oh, I, oh, yeah, we have instead of 0, yeah, so an initial data. Yeah, so basically it's solved. And it's solved within essentially 15 minutes with just a typo. And I think it's a pretty nice, elegant solution with a sliding window. We're using a hash map data structure to implement a set, essentially. We just want to know, is that a vowel or not? We have a set of vowels. So we're checking, is that character, is that letter on our set of vowels or not? So that essentially is, that's what it is, essentially. And then we have this sliding window. There probably could be another way to maintain that tail pointer, because we have a head and this tail pointer I mean, we can pronounce it. We can show it, just say, so the tail is head minus k, but plus 1. So that will clearly show us what we mean by the before tail. Yeah, the value before tail, what we care about. But it's kind of yeah, it's okay, I guess. Yeah, we could say that. Like that, even here, like tail is head minus k. And then we're checking if we is if tail, and yeah, if it's like 3 minus, yeah, if I mean, it's gonna make the code a little longer, but we're essentially checking is tail more or equal to 0. So no, is it more than 0? Because we need to be more than 0. Okay. And so there is a value behind it. And then we're going to say, okay, give me tail minus 1. So that. If tail, all good, except for this case. Tail is head minus k. It's 3, it's 0, it's 4, it's 1. Then if tail is, oh, wait a second. No, no, tail is not that. Tail is head plus 1. Plus 1 minus k, because if we are at 2 plus 1 would make 3, and 3 minus 3, so that's the tail. Yeah. But if tail, yeah, now tail becomes bigger. Yeah. Now it's right. But it makes it so it now it's I mean, we kind of explicitly we defined what the tail is, and we're saying, okay, now there's something behind tail. You get me that one value right behind it. So now it's clear. And yeah, it's more. But I don't know, for shortness, because for the sake of shortness, it's also fine. Yeah, well, anyways, that's yeah, we solved this medium level problem within pretty much 15 minutes, and pretty good result. So thank you for watching. Please like and subscribe if you like the video, and we'll see you in the next video.